Welcome, everybody. Thank you for coming to the Scientific Visualization 101 version on ParaView. My name is James Kress. I'm clearly not Thomas Teusel, but he's joining us via Zoom, so you'll talk to him here in a second. We're live streaming this again as usual. You can see over here on the side screen for those of you in the room. If you have questions, I'll try to repeat them. Tom will try to repeat them so that they'll appear on our live stream and others can benefit from the questions as well. We'll have several breaks during this workshop so that we can talk, answer questions, go through anything that you have questions on. But to start with, I'll just do a couple slides on introducing the VizLab again. I think most of you were here for the visit tutorial, but for those that weren't, the KVL team. So we are a 5-person team plus Tom. He's one of our contractors. We have all different focuses. Our lead, he's focused on information visualization. I focus on HPC SciViz, ParaView Visit, and in situ visualization. We have an AR/VR specialist and 2 data scientists. So if your research involves any of these areas and you have questions, you want to collaborate, these are our areas of expertise and we're available for those collaborations. So the KVL has 3 primary core services. We focus on training and workshops, data visualization and data science workflows, and then facilities support. So the first 2 are the ones that we focus 98% of our time on, more or less. So training and workshops, we have 3 different workshop series every semester. We have the scientific visualization workshop series. You're in the 2nd workshop in that series for this term. We have a data science workshop series and then an AI tools and techniques workshop series. If you missed any of those and want to check them out, they're all available on our YouTube, which I'll show you in just a second. And then we focus on data science and data visualization workflows. So HPC visualization, image segmentation, 3D analysis, AR/VR, and then large-scale AI and data science. So if you're interested in how do those expertise scale to actual projects, you can check that out on our wiki, see some of our current and past projects that we've been working on. Let's see, so that's available at wiki.viz@kaust.edu.sa. You can see a lot of different information there on our trainings, highlights, and more. And so focusing specifically on the trainings, the YouTube link is just at KAUST VizLab, so you can check out all of our past recorded trainings at that link. We have a ton of different stuff on ParaView Visit, Naviso, and Amira, not just these introductory workshop series, but we have different ones on some advanced topics as well. And these are some of the more recent highlights that were more focused on ParaView and Visit, so that's why I put these up here. But we collaborate in areas such as HPC visualization, scientific information visualization, AR/VR, and we're happy to work with you on collaborative projects in that area, or just give you advice. So we have a range of different services. We can give you advice, or we can actually work with you through your whole project, work on the paper, and actually help you get your paper done as well. It depends on what you need and what you're interested in getting help with. And so some of the cool projects we've done recently, we've done a number of things on HPC visualization, so over there analyzing particle advection performance. We've done stuff on hurricane simulations, this blog up here with Kitware. And then we also do open source software that we've released for doing in situ on HPC, and then a bunch of different stuff on AR/VR. Ronald's done a lot of work in that area. That's really cool if you want to check that out. So today, what is the point of this workshop? So it's really just a hands-on workshop. We want to not talk as much as we want to talk as little as possible. So it's going to be an introductory course, slides, demonstrations, and just get you into the code and get you playing with ParaView. Why should we care about ParaView at KAUST? Well, it's open source, scalable, and multi-platform, and there's users worldwide. And most importantly, it's available on all of the major computational resources here at KAUST. We've got it on IBEX and Shaheen. So we support distributed computation across IBEX and Shaheen, hopefully even on the Shaheen GPU cluster when that's available as well. But right now, the CPU partition is available. And of course, it has support for distributed computations to process very large data sets. That's really the power behind ParaView, and is that you can work on very large data sets. It's not just something that fits on your laptop. You can work on something that needs dozens of nodes in order to load. So without further ado, I think that was the last slide. We will transition over to Tom, and he will give us our workshop today, as long as I didn't lose him. Let's see. There he is. let me transition here and here. Nope, that didn't work. All right. So people can't see you yet, Tom. Are you speaking? Or we can't hear you? Apparently my microphone turned off. Can you hear now, Tom?
Oh, yes. I was not sure if I am already on.
You are not quite on. I've got to switch us on the stream PC. The button didn't switch you on. Your video's on, but your screen's not on. So we'll just fix that real quick.
My audio is on.
There we go. All right, you're on. So take it away.
I'm on. Okay, great. Sorry for this short technical interlude. So my name is Thomas Teusel. I'm going to do this Scientific Visualization 101, a ParaView Introductory Hands-on workshop. To get started, this is supposed to be a hands-on workshop, so best you have a ParaView installed. If you just want to sit in and watch, that's fine, of course, too. We're not going to check. But if you want to follow, install ParaView. If you have not yet, I'm just quickly show you. Should be easy. Everybody should be fine. You should get to this web page to download. You should automatically have the platform view on selected. So in my case, it's Mac OS, but the problem here is I actually have a silicon chip, so I would have to select this one. If you have a Mac, make sure you know which one version you need. Linux and Windows should be fine. All right. I'll talk a little bit again about the workshop, so you have time to install ParaView if you have not installed it yet. And I'll try to sync afterwards. You have a few important links here, which you should have received by email anyway, just to make sure. If you want to follow this workshop with the hands-on sessions, I would like to ask you to download the data set, at least here. You go to the workshop webpage, you have the workshop materials, and you can download the slides, the ones I'm showing. They're not very detailed because I'm doing most of the things hands-on, but there is the data set here to download. And you can watch a previously recorded YouTube video showing similar things, but with a different data set. Okay. As a motivation, I just want to quickly show you what we're going to do today. We'll explore this data set with ParaView using some basic visualization techniques. I'll talk about the data set a bit more later, but obviously that's the Red Sea and the Gulf of Aden here. I chose this data set because it has all we need inside, some scalar fields like temperature and salinity, and a vector field showing the flow in the Red Sea. And it's somewhat intuitive what it means. So even for people not working in this area, it should be easy to follow what we're doing. Okay, so we will do some basic scalar field visualization like color maps, slicing, and contouring. And then depending on the time, we have vector field visualization like arrow plots and streamlines. Quickly about the data set. This is a publicly available data set. The original data set is much bigger. You can download it. The download size is only 64 gigabytes, but it will decompress to 1.5 terabytes. That's because it's actually a ensemble and time-dependent data set. So you'll have a lot of data. We'll just use one time step, one ensemble member, and a smaller region actually for this introductory workshop. Okay, if you want to download the whole thing, you see here, you can, you have it here. This is the link up here is for the whole data set, and to download the part we're using, you can do that from the workshop webpage. Again, about the workshop course and agenda, James talked about that already, so I'm not going to repeat it, but we'll do a hands-on ParaView workshop, and ParaView is a good tool. You have all the support that KAUST on all the computational resources you have. So that's a good thing to know if you need to do something like this. So what is ParaView? It's an open source and especially general purpose visualization tool. So it does not care what the data is exactly, but you can visualize all kinds of data with it. And you see some examples here. It goes from regular sized things like a simulation of a tank, a scalar field around the tank, or a vector field around the racing car, to do a whole Earth simulations. Here's some winds over Northern America, or a Earth mantle convection thing, some combustion, but even down to small scale visualization like molecules here. You can do all of that with ParaView. And as I said, we're going to use a data set about the Red Sea today. But in principle, if you produce some kind of 3D scientific data, ParaView is a good choice to look at. A little bit about the architecture, that's not so important, but I just want to talk a little bit about VTK. That's the visualization toolkit. And I mentioned that because it shows up all the time, for example, in file names, extensions. So not that you're confused. ParaView doesn't have its own file names, file name extensions, but it's always using some kind of VTK. That's because it's built on top of VTK. Give me a second, sorry. So, but then on top of VTK, you have a ParaView server. So it's actually a client-server architecture, which is nice because you can actually use it on servers and on compute clusters and on supercomputers. You also have and then that's what we're going to use today is the ParaView client. You would have a few other things. You can use Python scripting or web-based or in situ visualization things. We're not going to touch these today. We just use the ParaView client. And that's just to let you know a little bit about how ParaView is built. Quick question, can you still hear me nicely? Something changed for me, but I hope everything is fine. So I assume everything is fine unless I hear differently. So this is today's, that's great. So this is today's agenda. We have this introduction, some 10 minutes. We're a little bit over it already anyway, but whatever. We're going to do some scalar field visualization. Then we'll have a break. And then we do this vector field visualization. Another break, and we'll see how far we get. And if we can talk a little bit more about ParaView. Again, the introduction, motivation, you've seen that, but just to motivate you, this is what we're going to do. Scalar field visualizations, slicing, contouring, and vector field visualization, arrow plots, and streamlines on that data set. Of the Red Sea, which actually has been generated on Shaheen 2 back in the days. So if you want to follow, what you have to do is you want to start up ParaView. That's what I'm going to do right now. On Mac, I press Command Space and type ParaView. You see I have two different ParaView versions. I take the latest one, 6.01. Should start up. I make it full screen. So you should see all, it might look, it even looks a bit different than my screenshot. I have a different color scheme here that should not confuse you. But what I want to do before we start is I like to have these property panels here separate, and by default they're actually combined, which in my opinion is not good, and since it might confuse you, So I suggest everyone splits up these property panels. The way to do this is you go to the menu, ParaView, Preferences. So just bring up the preferences like in any other GUI program. You have the general tools, a tab. So you might want to, you will actually have to, I'm sorry, I'm breaking up my voice. You have to select advanced properties here. I just deselected it because I had it selected. And then you might want to find this properties panel mode down here and switch from combined properties to separate panels for each type of properties. Because that's much more, then it looks the same as I have it, and I think it's much more useful than have them combined in one panel. You have to press OK, and probably restart, or actually you have to restart ParaView if you have this change this now so that for it to take effect. Okay, so if it looks like this now for you or most of you, we can actually already, I can show you why I do this. I have a white background. I don't know why actually. I just installed it freshly, so it came up with a white background. I don't like it. You can choose change these kind of things in the view panel. I like to separate them. In the view panel, you have in the view tab, you have everything that's concerned how your layout looks like colors of orientation axis and things like that, and especially the background. You have it down here. I just deselected. Now I have a background I like. And I'm going to talk about the other panels here in a second. So for those of you who first started ParaView right now, it should look somewhat familiar already anyway. It's a usual GUI program. You have a large display area where we're going to display our data. You have what's called a pipeline browser where the data you load and the things you do to the data will show up. So we're going to work with that a lot. And then you have these 4 tabs here, which are also important, which we're going to use a lot. And then otherwise you have a regular menu and the toolbar, which is shortcuts, which provides shortcuts for the most common things. So while going, I'll try to introduce you to this GUI a little bit. At the beginning, I know it could be a bit confusing because it's a lot, but we're just going to use a few things, and you will get used to the complexity of this GUI pretty soon. So now I want everyone to just load the data sets. I hope you have downloaded the data that we provide on the web page. You can just gonna load it. You go to open this either this icon here or to the menu and open, or you press the shortcut. Should bring up a file dialog. And then you navigate to the folder where you have downloaded the data. Since I have already selected it once, it shows it here under recent, which is pretty convenient. So if you're loading data more often, you can just go there again. You should have these 2 files, bathymetry and Gulf of Aden. So for now, I want you to load the bathymetry. Let's start with that. And the first things you notice, which confuses a lot of people also, is that nothing happens. That's actually on purpose, because ParaView is supposed to work with large data. We heard that in the introduction. And if you load something and do something to data which is large, it might take a long time. So ParaView actually lets you set some properties and parameters before loading the data. For that, we have to switch back to the Properties tab. Here we see it actually, we have only one variable in the data set, so it makes little sense. If I didn't want to load it, I could deselect it, but it's the only thing we have, so we're just going to load that one, and then we press apply. And that's one thing that... Yes, so Actually, I wanted to make a short break already now. With that setup, if everyone has loaded the data, and yes, and we're gonna sync here. Everyone has the data, and I'll try to fix. I'll try to fix. Yeah, I'll try to fix my voice, and then we keep going in a few minutes. Okay, I'll be back. All right, welcome back. Also now people online via YouTube. So I hope everyone managed to start ParaView and load the data. So it should look similar to you, not what I see here. You might have a different color map that might depend on your settings, or maybe you changed already something, or maybe I changed something with the default settings. I'm not so sure anymore. But that's the first thing actually what we're gonna do. Let me see. I should have something. Yes. So first I want to talk a little bit about scalar field visualization. So there are these two big fields of scientific visualization. The major fields. There are other parts, but the scalar fields and vector fields are usually what you have in scientific areas. And the first thing that we're going to talk about scalar fields. What does it mean? It means something like just one number per point of your domain. That number can represent temperature or pressure or height above sea level or something like that. And then you want to visualize, you want to look at it. We call it visualization, but people have been doing this all the time. And for smaller domains, like a 1D domain, it's a simple thing like just plotting the graph for temperature of your function, essentially what it is, right? So you have just a one-dimensional domain, like for example time. So you have one point somewhere where you measure temperature over, let's say, a few days, and then you just plot it over that time. And plotting a graph like that is probably the best thing you can do in 1D. You don't need a special tool for that. There are good graphing and plotting tools for that. Just MATLAB, for example. Take your favorite one. It gets a bit more interesting, but most other software packages can do that well these days. Is if you have a 2D scalar field, like let's say a temperature on a plate or pressure on a table or something like that, where your domain is only two-dimensional. There you have a few different options already how you can do it. You can do the same approach like in 1D. You can just plot the graph. And for example, let's say this is temperature on the plate, and you would know here's a low temperature area, here's a high temperature area, and so on. As a lot of tools can do that. But it's usually not a very good thing to visualize, or not the best one maybe, or there are other options. So for example, you have occlusions here, you don't know exactly what's going on behind this high temperature region, and things like that. So what people like to do in 2D is actually do what is called contouring. You should know these kind of maps from if you go hiking, or if you watch the weather report, you see it for pressure usually, where you actually display the 2D function, not itself, but only its contour lines, meaning the lines where you have a constant value. And here in this case, this is just a map with a height field. So you know that this, for example, is a mountain peak. You know how to interpret these images, that you have a steep rise here. It would be a bit easier to go up from here, and things like that. So you can also do that in 2D. You already have two different options. In 3D, it gets a bit more complicated. And that's what we actually, where you want to use ParaView, because that's what it specializes in. If you have a three-dimensional domain, like a room, some three-dimensional area, like the Red Sea, for example, what we are going to look at today. This plotting a surface, a height field doesn't work anymore, because we would need a four-dimensional space, which we cannot look at directly. But interestingly, this contouring works then in 3D as well. Essentially, it's the same thing. If you cannot, visualize it right now, what that would look like, that's exactly what we're going to do now in ParaView to let you get the experience with that. So these are the two things. Yes, what I want to do now. First of all, it's also a plotting tool, ParaView. As I said, if you have only images, 2D things, maybe other tools are as good, or maybe even better doing some things. But ParaView can also deal with 2D data. And what you often do in 2D is, although you have only a one-dimensional values as just real numbers, let's say in our case depth, because that's actually representing the bathymetry, meaning the depth of the Red Sea in meters. And what you often do, these are just numbers. In our case, we see it here between 0 and minus 3,100. And you just apply a color map. You give each number a different color, and then you see, that red is 0. For example, here we also see we don't have a topography, so we're not interested in the area. We're just interested in the Red Sea. This is just set to 0. Don't care about it. But here you see then that it gets steeper, a bit higher again. So obviously there's some mountain hills in there, and pretty deep down there. Blue is the lowest parts of the Red Sea, in this case of that region of the Red Sea. So if you don't like that color map, people have all kinds of preferences. Excuse me. That's you can change that, and you can do that in the display tab. That's why I like to separate those tabs here, because then you have everything that relates to displaying things of your data is under display. Everything that is concerned with how your overall view looks like background and things like that, is under view. Properties is how to load your data, and how to set some parameters for it, and for the algorithms we're going to use later. And then information, it's actually an interesting tab. And information, you just get an information about your data set. So that's actually quite interesting to look at first, so that you're sure you're looking at the right thing. We have our bathymetry .vti. Again, I said ParaView is built on VTK, so VTI means it's a VTK image file. 2D image in this case, just a regular image. And you have some technical things if you're interested in those, like how much memory it takes up and what exactly the grid is. We're not going to care about that too much. What's interesting is first we see our variables we have here, which is depth and its range, which is often quite interesting. And we see the actual bounds of the data. So the x-axis here actually goes from 42 to 49, and the y-axis goes from 10 to 15, which is latitude and longitude, or longitude and latitude. I always confuse those. And in C, we actually have a delta of 0 because it's still just an image. 2D image. It doesn't have any extent in 3D yet. The 3D values or the depth are given actually as values of the image. Okay. If you don't like the color map, go to display. Here you have the first thing you should see is the coloring. You can choose by which color you want to, by which variable you want to color. We only have one. You should keep it at depth. And then the color map is actually this icon here with the little heart. I have no idea why a color map is supposed to be represented by a heart with a folder with a heart, but that's what it is. If you press it, you get the usual color maps editor. Since a few versions of ParaView, they actually have it now a few groups of color maps. So these are not all of them. These are just the most commonly used one. If you want to see all of them, just press all over here. And then you see you have a lot of different color maps. I'll try to move that thing a bit to the side. And you can choose whatever you want, just black and white, X-ray, bluish, greenish, whatever. I'll stay with the rainbow. Rainbow decider. I think that's the one I have on the slides. Either double click here or select it and press apply. Okay, and then when you're done, you can close it. And you have a different color map. And now we want to explore it a bit more in 2D now. We can actually do the same thing we have seen before of that height map that we've seen from some mountains and things. We can do it on this image as well. We just want to show contours of that bathymetry, and the filter that's why we now use our first filter. That's called in ParaView. It's called a filter. That if you apply something to your data and it produces something new. So if you look at your pipeline browser, we have our bathymetry here represented. Now we can apply filters to it, like this contouring filter, which will produce a set of lines, which will then just display as lines. So make sure you have selected your bathymetry, and then you can generate, use this tooltip here, generate isolines. And the filter is actually called contour. I'll talk about that in a minute. That's actually important. For now, again, the interesting thing is you realize that nothing has happened. Again, the reason is when you do something to your data, generate some new data, you always have to hit apply. And this is always under the properties panel. So I was on the display panel. I didn't see an apply. You might get confused. Why is nothing happening? You have to go to properties and hit apply. Before we do that, as I said, the reason for that is that you might want to change a few parameters of in this case an algorithm like contouring. There isn't much interesting here, most of the things. So we want to contour by depth because that's the only variable we have. The other data we're going to load in a second, we have a few different variables in there, so we could choose between different variables to contour. In 3D, you might want to, so if it's a 3D data set and you actually generate a surface, you might want to compute normals. We don't need them here, but it doesn't matter if they're selected either. And some other things which are not that important for this kind of data. The important thing is actually here, the isosurface values. So this value will now represent or determine what kind of contour line you will get, or you will get the contour line for that value. In our case, we want minus 1,500, or ParaView suggested to use minus 1,500 meters. That's probably essentially because that's half in between the value range we have, right? Let's just try that. Let's see what happens. So if we apply, I did hit apply, and you see it usually that it did apply by the button grays out, and your filter here actually gets white, proper white, but we still don't see anything. Again, it might be it is actually confusing in my opinion, but there's a reason, pretty simple reason for that. In order to show that, there's another feature of ParaView here in the pipeline browser. As I said, it shows your data and the filters and the algorithms you apply to this data. So we have loaded one data set, bathymetry, and we applied the contouring filter to it. You might not want to show all of that at some point, and that's what you can change that by clicking these little eye icons next to your data set. So since we just generated the contour, but we don't see anything, one idea could be that our original data, the bathymetry, which we still display, is obscuring it. So we could just deselect that here, and that's actually the reason. It's exactly the reason is that the contour gets the same color as the value that the data set has at that point, so you won't see it if you just display it with your data. If it's selected again, here's the contour. Somewhere it has the same greenish, yellowish color than your contour you have here, so you don't see it, which means we can change the color of the contour to actually see it on the plot. And for that, again, as I said, changing colors and appearances of your data is always under the display tab. You go to your display, make sure you have contour selected. You can, if you select bathymetry, you would apply everything to bathymetry, but you want it on the contour. And we can change the color here. So in this case, for example, I don't want the coloring by a color map. I just want some color. And you see it here now. I'm not sure you see it on the screen, but on your own laptop, you should see it. That now it says thin white line. I can actually increase the width here a bit so that it shows up better. But this is now the ISO contour of minus 1,500 meters. And yes, another learning point here is to again push the point why I split this up into the four, why I like this layout the best is it also makes me, it's easy to remember that whatever you do in these three tabs, here information you can do anything anyway, just look at your properties of your data, but in display and in view, you can change something and it will take effect immediately because it's just usually changing some color, changing some appearance, and that will just happen. Whatever you do on the properties, you will have to press apply afterwards. And that's a nice separation of what to do. So for example, I want a second ISO contour. I can just add one here, and let's take minus 500 meters, for example. Again, I have to hit apply. Now you see you have a second line there, which is minus 500. So to create this like a contour map like we've seen before for a height field, you could now just keep adding numbers until you have enough as you want. That's a bit tedious. That's why ParaView provides a shortcut here, which comes in often very handy. So I want to show that. First is you will have to delete your already the values, the ISO values you have created, because we're creating new ones. You just have this X button down here where you can delete everything. And the button above, which in my case doesn't actually show anything, it's just a gray box, funnily. But the tooltip says add a range of values. That comes in very handy to create just a few values automatically. So within a certain range, and we want to span the whole range of our values of depth. We have -3000 to 0. We want just a number of samples equally spaced. Linear means just equal spaced values in between this range. So you see actually exactly the values ParaView will now generate for you. So you could do the same thing by pressing add 10 times and putting in that number. Here you just press it once. You say, actually, I want 20 numbers. It will generate these 20 numbers. You hit generate, and it actually explicitly adds them. So in the end, it's exactly the same as if you just had added 20 different values here. That's quite handy. If you then hit apply, you see your 20 different values. Okay, so this is a way how to generate these kind of height maps we have seen, which is a common way to visualize to the images, the scientific data, like height, fields, temperature, pressure. All right, let me know if I have to should slow down a little, or we have done that, because I would go to actually creating the height field. We are not so much interested in this 2D image here. We want to use this as a context for the actual data we're given in the Red Sea. Okay, so I'll go ahead unless I hear something different. Because before I want to do that, okay, so to interact with your data, by the way, I haven't talked about that yet, but it's pretty straightforward with one caveat, which I want to talk about now. So ParaView is a 3D visualization tool. This is just a 2D image. So it's actually switched automatically to 2D mode, which you see over here, which, for example, means that if you press your left mouse button or trackpad area and then move around, you just drag the image around. Yes, you can just move it somewhere else. If you use, I think it's Control and then up and down, you can zoom in and out a little. Well, on the trackpad, you can just do it with two fingers up and down. Also zooms in. And that's a 2D interaction mode. And we only have 2D data here, but we can still switch to 3D. And we see actually that although it's 2D only, ParaView treats it as a 3D data. We can now rotate around it. It's just an image lying in space. Okay, so whatever you do in ParaView, it will always be 3D somehow in a 3D space. And this 2D mode is actually just restricting your interactions to the plane. So if you, for example, switch back to 3D now, it's still rotated, but if you move that, it just drags around. It restricts your interactions to the and if you want to go now looking at the image like it was before, there are a few handy buttons over here that align your view to the axis. And since we want XY plane and C sticking out, we press this one and we see the image again. You can try the other ones, then you see the image from the side, meaning you don't see much. But if you go to 3D mode again and rotate a little bit, you see it has just switched to this layout. For an image, you want 2D, and then align. If you're not aligned with the Z-axis, you want to align it with this button to your image plane. But we want to create actually a height field now explicitly. As I said, the second visualization technique for scalar fields you can do is actually plot it as a surface in 3D. That's what we're going to do. For that, we turn off the contours. I don't need them anymore. We actually switch to 3D mode because it will now be 3D. Okay, I'm gonna rotate a little bit, move it up here. And what we want to do is we want to now move each point according to the value that it's there to its actual position in space. And there's a filter for that. You might expect something like create height field, generate height field, but that's not it. It's actually called warp by scalar. You have to know that. That's why I put that one on the slides, because this is really hard to remember. And very important is you have to select your original data. Another thing for ParaView is whatever you do, if you add a new filter, if you do something, it always applies it what is selected here. Okay. Now we want to scale this image by the values that are in there. And I said it's called warp by scalar. We're going to add the first filter, which is not on the toolbar as far as I know. So you go to filters. Now you have to find it. When you know what it's called, under alphabetically, and then you just go to warp by scalar, which of course is at the very bottom. On Mac, it arranges all the filters in one big list. I think on Linux and Windows, or one of those, it's actually a rectangular where you see more of them, but whatever. You want to find this one, warp by scalar. And there's not much to do, actually. The normal says in which direction we want to warp, which is usually the Z direction. That's exactly what we want to do here. We want to move this image in Z direction according to the values. And the scale factor is 1, which sounds reasonable. Let's try that. Hit apply. And that's what's happened. That's not what we expected, and what I expected the first time I did it. It looks weird. Just too much. The reason, that's why I do that, and I want to talk a little bit about the ParaView. The important thing is, I said in the beginning, it's a general purpose visualization tool. It doesn't know anything about units. It does not handle units at all, because it wants to be a tool for all kinds of areas, and that would just be not doable, in my opinion. You can never read everything correct. And that means the strategy ParaView is taking is that that the user has to know what he's doing. That's us in this case. And the reason why the data looks strange like this is that in X and Y direction, we have our values given in latitude, longitude, or the units are latitude and longitude, and in depth with meters, and that doesn't fit together, right? Which means we have to scale with a different value, which approximately corresponds to or converts meters to latitude, longitude. Approximately, only possible anyway, because latitude, longitude is not a constant unit. I have put the value I need here, actually here, I remember it myself, 0.00152, then it should look somewhat nicely. Hit apply. Now it has gone again because it moved up. So I press this. Now I have moved my zoom menu on top. There you go. I press some of the alignment buttons here. Probably this one is not a better one. And now we see that we actually have moved all the values to its actual position according of the depth. And that's essentially the bathymetry of the Red Sea. It's a bit exaggerated because if you do it's exaggerated by about 10. If you make it 10 times smaller, that's more physically what the Red Sea would look like. But then it's very thin, very shallow, and it's difficult to then see things, what happens in depth. So one common approach in visualization is to not stick to physical reality if it improves the visual appearance. And of course, it's dangerous. You have to remember that that's not exactly what it's physically like, but you should see better what's happening in there. whatever. You can always change your scale factor here. And the next thing I don't like is that I now have this plane of 0 value. So we just multiplied each value, each point by its value and moved it to that position. Since all of these are 0, we just have this plane there. And just having them 0 just means it's not, there's no data there. It's essentially a replacement for missing values. And I just want to get rid of that, and this gives me the opportunity to use another very useful filter, which is called clip. You often want to clip your data because if it's 3D, it always something obscures something, and clipping your data is a very, very common thing. And you do that again here on the toolbar, clip. And then you get a bit more of an interaction thing. So you can clip by this plane. You can move it around just with your mouse, select it and move it around. But that's not the direction you want to clip. I want to clip off the top, right? So I reorient this clipping plane to the C normal because I want it flat. And then I could move it up now somewhere, but I know I want it just to be slightly below the surface, which is 0, so I take some small number here for the origin of the plane. So a plane is specified by a point and the vector, right? And the point now is slightly below the surface and the vector is up, so I should get this plane. And I see it here actually. If I hit apply. There you go. And that gets rid of the values we are not interested in, and we see only the Red Sea and the Gulf of Aden. One inconvenient thing here now is usually you clip things away and then you want to rotate around, which you do here, but often you hit the thing and move, which you didn't want to do. You can immediately just hit the reset, which puts it back. And then what I usually do is I deselect this show plane. Once I know that's the one I want to use, I deselect it here, and it's just not shown anymore, and nothing can happen anymore if I interact. So this is now the Red Sea. And this is essentially the area we are going to look at now with some simulation data. But we don't have the simulation data yet. We're going to load that now. And that's the same way we did before. Hit open and just load the Gulf of Aden. Again, nothing happened. We have to hit apply. Before we do that, take a moment and think about, is that really what we want? We have now 3 variables in this data set: salinity, temperature, and some vector field. In this case, I want all of them. You know, if your data set was really large, you might not want to load all of the variables. You might not be interested in all of them at some point. But in this case, it's small enough, and we're going to look at all of them anyway. So we're going to load up all of them. Hit apply. And the next thing, again, sometimes confusing. People first working with ParaView. If it's a 3D data, you don't see much again. But what has been added is this called a bounding box. So that's the default view for 3D data in ParaView, because it might be big, it might take a long time to actually visualize it, to just plot a box around the around your data, so that you know at least where it is, and it's at least we know that our data is nicely aligned with the Red Sea bathymetry. So we have obviously done this correctly. I don't like the black on the gray outline, so again, just can go to display and change the color. So here I want a solid color for the outline. That makes little sense to use some variable there, but I just want to change this black to, so I hit edit here now actually and make it white. Hit OK, for example, or whatever. If you prefer yellow, you can make it yellow. I go back to white. Anyway, so this is now what I wanted to show a little bit about 2D scalar data. And I want to move to 3D scalar data. like slicing and contouring in 3D. Before I do that, I think at least I want to sync with you guys. Should I go on? Do we want to make a short break? Is everyone in sync? We're good to go. Then let's. Nobody's having an issue. Yes, absolutely. Just get in touch with James if you want to. If you're there at KAUST. If you're on a live, you can use the chat. I just keep going now with the 3D scalar fields. If you don't have the bathymetry, that's not so important if you just want to follow now, because then you could just look at your data without the bathymetry. Will be fine too. Actually, let's select the bathymetry. The one thing I don't like here now is that the color map for bathymetry is not great. That's not too important a thing, but it's quick to change. I choose a different color map, and for a bathymetry, I don't know, something brownish is probably appropriate. I have some brown here. I use that. Looks a bit more like a bathymetry. So, and now we actually want to look at our 3D data. Our 3D data is this Gulf of Aden data set, so we have to select it if we want to do something to it. And we can go again to information. Always a good idea, as I said, to take a look if everything is correct. It looks fine. We have three different variables here. Salinity and temperature are scalars, because you see that the range of salinity is between 0 and 41, and of temperature between 0 and 31. And vec is obviously a vector variable, because you have to actually move to the right. You have the ranges of all three components, right? So the x component range, y component range, and z component range of your vector values. Not so important by itself, but it's good to know and be sure that this is actually a vector variable, and these are two scalar variables. I go back to make it a bit larger, like this. And if you're interested, again, you see that a bit of technical information. If you're interested in that, you have a structured curvilinear grid. The number of cells and points takes about 100 megabytes to store that data set. And again, now the important thing is the bounds that are actually physical bounds between 42 and 49 and 10 and 50 and 10 and 15, that is the longitude. But now we actually also have an extent in z direction, and you see it's between almost 0 and 3.9 negative value. So okay, so that looks good. Let's take a quick look at let's say one of the scalar variables. Let's pick temperature. It's maybe a bit more intuitive for most people what it means. We have this temperature now distributed over all of the reds of this area, 3D area. So it is a bit difficult to display it. Usually, a good thing to get an idea of what's going on is to slice through that data and just visualize it then again as a 2D image, for example, with a color map. Let's do this. The first thing. That's what we do. Let's go back to properties here. Always select properties when you start doing something on your data. Make sure that you have selected the Gulf of Aden, and let's slice through the data. We do that with a filter which is called Slice Data Sets with Planes. Let's just hit it. And we get the same widget as we had before, that's where we're actually clipping away parts, but this now actually just represents a slice. But I want to do essentially the same thing. I want to see what's going on the surface. Let's say that's probably the first thing. Go slightly below the surface, maybe not like the clipping plane. We should stay inside of our data. So let's go a bit lower, minus 0.01. I think I clipped at 0.001. We should see. Hit apply. There we go. So again, I immediately wanted to rotate things around. I might change the plane. So what I do is I turn it off. But now I see my plane here, but nothing on it yet. This outline you see is actually the part of the bathymetry which sticks out a little bit because we were moving a bit lower. If we want to see some values, we actually, slides should be selected, but always make sure you have the correct data selected. We can display something on the slice now. For now, it just displays the slice as solid color, which is pointless. We just know where it is, but that's all. But we can just choose one variable we want here now. Let's take temperature. Okay, that's what it looks like. We can align our view since it's essentially an image again. It is 3D. So now we see it from top like that. Let's say there seems to be something going on, but there's a lot of blue stuff here, and it's the same problem, especially with this data set, but you have it often with these kind of scientific data sets. You don't have useful values everywhere. And in this case, the temperature was just set to 0 again on the topography because we're not looking at the land area of this region, but only at the sea area. But we have to put something there. You cannot store not easily data only in these regions, right? It's easier to just store a whole block and then don't put anything in there. In this case, it's 0. But that messes up our color map because it's actually the temperature doesn't start at 0. So one thing which works here nicely and which is probably a good thing, if you know that you have one value which represents missing values or uninteresting parts, just clip it away again. Let's go to properties, make sure you have a slice selected. We cannot do that with the clip filter now, but we have to use one that's called thresholding. It's called the tooltip says extract cells that satisfy a threshold criteria. And that's what I want to do. I want to threshold by something a bit smaller than 0 because 0 is the value that's not interesting. So I just, first of all, make sure you threshold by the correct variable. In our case, it's temperature. We could use salinity. It should be pretty similar. And the lower threshold is not so important, something larger than 0 and not as large as the smallest temperature in the Red Sea, which is, I think, about 27. So if you use something like 10, it should be fine. Or just 1. Hit apply. And now we've seen we have just clipped everything which is outside of the Red Sea. But the color map still looks like only, not using the whole range because it's not. We have the color bar, the color map here. By the way, you can, if you don't like it here, at the moment I don't like it because it's overlapping with my zoom window. I move it down here. Just select it and move it somewhere else. The problem is the color map is now still going from 0, which we know we don't have anymore. We go to display and we can rescale our color maps in a few ways, but the easiest, especially in this case, is to just rescale to the data range that we have now here. If you hit this button, you have it now rescaled to the whole value range you have on that thresholded part of the data that you're interested in, which is just the top slice with all of these parts removed because they were 0. And that's now looks much more interesting. First of all, and also reasonable. First of all, the temperature in the Red Sea obviously gets much higher. And the closer we get to the larger oceans in the east, the cooler it gets. But there seems also to be some intermixing here, which is probably interesting for a domain scientist. Okay, so that's a way to look at this scalar field, but of course we only see part of it. Okay, we're not interested in these parts, but we're missing the whole region and values which are actually in the Red Sea. So you can align the view to different default views, axis aligned views with these buttons up here. I do that, and I see I have my plane on top, but I'm missing the whole region here. I want at least know what it looks like in some of these slices again. That's easy to do. That's what we can do. We just And that's now important again. Make sure to select your data set again, Gulf of Aden, because you can attach another slice to this slice, but it will just produce a line. It will not, at best, if you place it in a direction where it doesn't intersect, it will be empty. We want to slice again our data set. So select it here and slice. What happened? And now actually I'm going to move it manually. Yeah. Because the direction, the orientation I like is the one I want. Let's move it somewhere maybe here. Again, you have to hit apply. I didn't have the properties panel selected. You always have to do that. Can be confusing, I know. And hit apply. If I like the plane, I immediately deselect this, so I'm not going to change it anymore. And now again, we can display some property on this plane and do temperature. Again, and again, you see you have the same problem that this is all 0. It's not that big the problem now because values get rather close here, rather small here anyway. But I'm going to clip that away again, nevertheless. So make sure you have slice 2 selected and do the thresholding again. You have to go to properties and again, some threshold larger than 0. Okay, and now you have a plane here. And probably I always do that immediately. I rescale the color map because this thresholding usually changes the range, but it doesn't automatically update. But it also means, since we have the same variable on both slices, that this one now got rescaled to the larger range that we have here. But most things are red here. And that's not... you can either scale to the one range or the other. At the moment, I'm interested in this one because this actually shows some interesting, for me at least, not a domain scientist, but also I think reasonable things. You have high temperature region on top. That makes sense. The water on top heats up and it gets cooler the further down you go. But it's not the linear thing. You have obviously some intermixing temperature stuff here. And to make that more obvious, we can use our 2D visualization techniques we had before. And for example, just do some contouring here with, I'm going to delete the default value. I want temperature. Delete the default value and generate, let's say 20 numbers again. Hit apply. Now it actually turned off this one. Don't know why I did it in this case. But now you see it nicely that you actually, most of the time you have, it just cools down. If you go down, there seems to be some region where some things are intermixed. And that's, if you do the simulations, the domain scientist now has to decide, you can explore your data like that and find out these kind of things which you might not have expected, and now you can take a closer look. Why is that happening? That's what the visualization is there for, just to look at your data and find out things which you might miss otherwise. I don't know if they would have missed that. That might be obvious anyway, but you see it at least nicely and immediately that there's something that you have some region here in depth where things are happening. Okay. What's the time? I am already taking too much time. Okay, quickly, I'm just going to quickly show it and then we make a break. The nice thing in ParaView is that you can do this contouring, of course, not only in 2D. We've done it so far only in 2D, but you can do it completely in 3D. And the nice thing is you use the same filter, you just select your different data. Now, I did the contouring on a slice before. I had the slice selected. Now I do the contouring in 3D and I I select the 3D data. So I do contouring, and I use the same filter. I do temperature. Let's say I want to know let's keep that value. So we will get the surface which separates the temperature region which are higher than 20 degrees and lower than 20. 20 degrees is too little. Let's make it 30. And hit apply. Let's see what happens. That was too much. 30? Yeah, 30 was too much. 25. There you go. So we see this is now a surface actually. Everything above, or in this case above that surface, is higher than 25 degrees, and everything below is lower than 25 degrees. So you can again try to find out. We're still 20 degrees, still quite up there. Let's try 15. And so on. So we're moving down, and there you see again that now obviously this isosurface is already spreading out in C direction. So 15 degrees are in this area. Obviously, there's some intermixing of degrees. That's what I wanted to show quickly, that you can do this contouring now completely in 3D and find this isosurface of your 3D scalar values. I say we make another break. You can ask questions either live or on YouTube in the chat, or and we're gonna meet in. I'll be back in 10 minutes, right? Yes, go ahead. Yes. Yes. In principle, yes. So the first thing is I mean, that's one of the difficult things, and often that you have to load your data. But if you go to open and just look at what kind of data you can load, there are a lot of different things, right? Even from different simulation software. So, for example, OpenFOAM, people like PFD, people like ParaView a lot. So there's OpenFOAM in importers, and all kind of image types and scientific data types, which I don't even. Fluent is another CFD thing, right? So if you, or Insight, if you're using these kind of simulations, there's a good chance that ParaView can just load it. You can just load an image by itself if it's just some image like. Do I have some image? I should have some images because there's a small caveat there. Well, that's the problem, because if you load an image is usually in some kind of RGB, right? So you will have to convert it to a grayscale image first. You can do that in ParaView, or you can do it in some other tool, but you cannot contour an RGB value. You can only contour a one valued variable. Does that make sense? Yeah, if it's really colored, right? But then I'm not sure. You might want to talk to James in person afterwards if that makes sense what you want to do. But usually I would say pictures here. Do I have some? That might be a nice one. It is. Just have to deselect. So this is, for example, an image I created with ParaView with some molecular data. Doesn't matter. But you see, it's RGB, and you can actually go here. You see, it's really RGB. Everything is between 0. Actually, blue is only whatever, restricted. But you have to undo the color map if it's really a color map. I don't think that makes a lot of sense because you should get a hold of the original data. But if it's already, let's say, a grayscale image where the gray value represents your depth, then you would have everything just, let's say, just a range of 0 to 55 in one channel and all the other 0, for example. And it would show up as red. But then you can convert it easily to I can show you, or James can show you it later. You could easily convert this now to a grayscale image by just using one of the values, right? If you look now at information, it has only one range result, and it gave it result. The old one is still there, but this is the new one. So we want to display by result what we do, but it still applies the color map. So I would now go to this is the grayscale image now, and I can contour that now, for example. I don't know if it makes a lot of sense, but in this case, it makes little sense because it's an image. But I can still do that, right? The only thing is I have to really convert it to a one-valued variable so that it makes actually sense. So we have some, yeah, so these would be the contours of that image. You have to know what you do. In this case, it makes little sense. If you have, if I understand it correctly, you have a bathymetry or a depth image, which is a colored image, and you want to contour it, right? Yeah. It sounds doable to me. I would suggest that you talk to James afterwards, and if you can provide us with an example, we can, probably even James, but I could also take a look at what you want to do. Okay? Welcome. I'm gonna delete that one here, and that one, and that one. Okay. All right, are there any more questions? Should I repeat something? Is it too fast? Does someone want to follow and it's just a bit behind? Let me know. We have a half an hour left, I think, so I would want to at least show you a few vector field visualization techniques. Unless I hear anything, I'm just going to proceed, so we will have enough time for that. Okay, good. Okay. Go ahead. Yes, I can hear you. Yes. I'm not quite sure. I know I understand what you mean. So let me try doing it. You have an image like this, right? And then you do the WordPress scalar. Then you have this. This, yes, this is just a height field, or just a image displaced by that value in a certain direction with a certain scale factor. Okay. Yes. Yeah. That is. So if well, then you actually, yes, then you probably have it colored by solid colors. You want to color it by depth. So in the WordPress scalar or in the clip, actually, if it looks like that for you, then you probably have solid color here, right? Right. So if you go ahead. You good? Yeah. So if just to wrap that up, if I got it correctly, if you have something which is uniformly colored, so it's just one color, then you usually have in the color in the solid color selected. Could be selected automatically by ParaView. Usually it keeps the variable, but in this case, it switched for whatever reasons. And you always want to check that you're coloring by the correct variable. In this case, depth. Okay. Then I'd like to quickly, 15, 20 minutes, talk about some vector field visualization techniques. I did that. Yes. Vector field visualization. So vector fields, again, the second, in my opinion, and experience, largest area or type of data that's produced in scientific areas. It's describing some kind of movement usually, right? Water or air. And it essentially says at each point you don't have only one value, but you have a vector with a magnitude. Or since we have a coordinate system defined, 3 values per each position in space. And it makes things a bit more complicated to visualize, but there are a few standard techniques, and we're going to look at two, at least one. Let's see if we get to the streamlines. Because actually you can play around a lot with error plot. These are super simple techniques, but very powerful. And you can play a lot around until you see what you want to see. But the idea is just you have given data points where you have your velocities, for example, in this case given. You just display each one as that vector that it is. Has the advantage, for example, that you don't need any structure on your data points. If you have just some measuring points distributed in space with, let's say, some measure sensors somewhere, you put some sensors somewhere, you can just visualize that with vectors. And that's what we're going to do. And that's what ParaView can do, and that's what we're going to do. And streamlines is similar. So essentially, a streamline is a line where each point of that line is actually aligned with the vector there of your data. So you see it in this example that the line essentially follows the arrows, right? Also called integrating the arrows or the vector field. Usually done numerically, definitely ParaView does it numerically, and with some runge koto, you can actually define which scheme you want to use, not so important. Can do it for you. The more important thing is how do you use it to actually produce nice images that show what's going on in your data. And we're going to try that as well. Let's start with arrow plots. If you are at this, so if you have followed so far, at least partly, you should have the clip, and that's all we need to see the symmetry. Again, as a to see the first thing which I usually do is to just plot some arrows for the vector field to see maybe something interesting what's going on. And there's one filter in ParaView to use that. Again, you have a shortcut for it on the tooltip. On the toolbar, it's called generate glyphs. Let's just hit that one and go to properties. Always use the properties. Let me scroll it up a little. So there are a bit more parameters here to set. I want to go a little bit through them. Most of them are not so important. The glyph type, we want to use arrows. You can use different. This is simple. You can just switch them and look what it looks like. But usually an arrow is because that's what we just want to do. That's why we call it an arrow plot. We want to use arrows. Then you can choose some resolution of that arrows. If this is rather low because you might produce a lot of arrows, it's better not to have too high resolution for each one. But if it doesn't look good enough, you can play around with make it smoother. That's not, but it's not so important then. Orientation array. This is funny. Yes, I made the first mistake. See, there should be an orientation array here. It is not. Why not? Because I have attached my glyph to the wrong data set. I have attached it to the clip, which is just this surface. I don't need it there. I delete it again. By the way, if you did a mistake, you can select the filter and just delete it. I, of course, want to attach the glyphs to the Gulf of Aden. So here we also have the vector field, which you're going to need. Make sure you have the Gulf of Aden selected. I made sure now and hit. Okay, now ParaView complains that it might be too much, but I know it's not going to be a problem because I know how many arrows I can do. Funnily, I tried that yesterday and it did not complain. Today it does. Yes, and don't ask again. I'd press yes. Let's see if it shows up again. Okay, same thing here. We select the arrow. Don't change anything of the resolution list. Now we have this orientation array here. That's where the arrows now will be oriented with. It's the only one we have, so it's the only one we can select. This scale array is a bit complicated, a bit unintuitive, in my opinion, to use. If you say no scale array, then each arrow will be normalized, which to me is not no scaling, but fine. That's how ParaView uses it. If you want to show the vectors with their actual length, which they have, you have to scale the vectors by their own magnitude. So you use the vectors themselves, the scale array, and then scale by their magnitude. That's how it is. I don't think it's very intuitive, but once you know it, at least it's not that confusing. And then you have an overall scaling factor. That's something you have to then try and see what it looks like. We don't need any transforming and masking of the glyphs, but the most important actually parameters we need now is we need to select what arrows we want to display, and we could say all points, for example. Problem is with free data, these are a lot of points. These are millions of points, and probably Barry would even crash if I tried that now, because on the whole data set it's just automated. I'm not even gonna try. But that's also why by default it's uniform spatial distribution. It's so meaning within our bounding box that we had before, it just randomly distributes a number of points and how many I can select here. It says 5,000. That should be fine, and we can always change that easily. There's a seed thing, so if you want to change the randomness somehow or reproduce, you can do that here. But just for a quick visualization, I just distribute 5,000 points randomly in the Red Sea. Let's see what it looks like. Yes. What's that? Come again, sorry. The glyph mode. You have to scroll down to the very bottom. It should be there. It must be there. That's the most important property here. They don't need any. You don't need it. Yeah. So here's an. Oh, I'm sorry about that. I wouldn't have to talk about the resolution because I have the advanced properties turned on. I'll turn them off for now. So you should only see. You can turn on and off advanced properties here. Often some useful ones are in the advanced sections. That's why I always have it turned on. But we can turn it off. So you should have only these properties here. Oh, really? Interesting. I don't think it's good to know because it's stupid. But anyway, now I know. Yes. That's why I use. No, that's not the reason why I use, because even on the combined panels, this property should not be on the advanced, because this is one of the most important ones. It is, it's an, well, but whatever. If you don't see this, try the advanced properties. If you are on the combined, again, I would recommend splitting the panels, the tabs into these 4 groups. But anyway, so you should have this. Does it work? Okay, good. So what you and you should have this kind of immediately this kind of image, which is nice. So you already have some idea of what's going on. But the one thing is, let's look at it from the side, from the front. Actually, in this case, that also makes a lot of sense. Is that you have huge velocities on the top of the Red Sea, and the lower you get, they are rather small, right? That makes sense, but that is a problem for visualization because you don't see the arrows down there because these are already so large. We can increase the scale factor to, that would be too much, to 1, well, let's say 2. Then those get a bit larger, but they get huge over here, right? So that's not exactly what we want. Or that's something you can play around forever with these kind of parameters in the glyphs to get and see what you want to see. You could try actually normalizing them. Again, normalizing in ParaView is done by saying no scalar, right? Doesn't make sense in my opinion, but that's what it is. Now they are much too large. And we see another thing. Okay, let's make them smaller first. Try 0.1. Too small. 0.5. Yeah, a bit better. Still too large. Yeah, 25. I'm a bit picky. Doesn't matter. Okay. So now we see them all in the Red Sea area. They are normalized. Again, you have to know what you do and what you're looking at, because that doesn't mean that the velocity is as large as on top, right? Just normalized. And then the other problem is that we are seeing all these errors on the outside, which how to say, again, or the data, how the data is created is, we're not interested in the area outside. Since it's storing it in a rectangular region, it has to put something there, and we put 0 there. And then when you normalize a 0 vector, you have a problem. You cannot do that, right? And ParaView has to do something. And what it chooses to do is that it replaces a 0 vector by a normalized 0 vector by a unit vector in X direction. Don't know if this makes sense, but that's how, at least how it is. And that's why we see all these arrows here. But we can do the same thing as we did before on the slice. We can actually clip the whole data set, in this case, by, let's say, let's clip it. But not clip. Sorry, threshold. I want to threshold it. We did it before with temperature. Let's do the temperature again. Something a bit larger. So now we see actually we have only the data inside, created this threshold. I actually don't want to see it, but I only want to attach my arrows now to this area, because it's I don't want that. And there's another feature which comes in handy often is I've created these glyphs, but I've attached them to the wrong arrow, to the wrong data set. I could delete it and recreate it, but then I have to remember all the parameters and so on. I can just right click it and say change input. And then I move it to my threshold. And now I have them on the inside, because I've clipped away all the outside arrows. Okay, so that's how to get a quick overview. Let me go back. I don't like the normalization. I don't think normalizing a vector field is a good idea, because it's wrong. It's not showing how it is. They are not too small. I think we could just use a few more. Let's make 10 times more, 50,000. Okay, so you see now a bit better what's going on. Maybe they're even a bit too large. But anyway, an easy way to visualize vector fields. In 3D, the problem is that you have to select the positions where to put the arrows, and it's could be confusing. They are overlapping. It could be that these are far away but larger, or they're actually close and small. That depends on the projection. You don't really know that. You can often infer it from the overlapping, but that's not for sure. So it could be confusing, but it's a quick and easy way to get some idea of what the vector field looks like. 10 minutes left. I'll quickly show some streamlines, and then let's take a few more questions, unless there are questions now. I'm good. I'll quickly show you the second technique, so that you have seen it and how to do it in ParaView to do streamlines. That's the second most popular visualization technique for vector fields. Unfortunately, they are still, but even a bit more complicated and trickier to get nice images than arrow plots. But anyway, since I Hello. My Zoom crashed. Sorry about that. I share the screen. Am I back? Oops. Yes. Okay. Sorry. Complain to Zoom. I don't think I did that. Maybe I moved my mouse pointer too fast, and I think I know that. We are lost 2 more minutes. I want to quickly show you some how to create streamlines, and then let's take a few more questions. So again, I said, that's what I was talking when Zoom crashed. I'm not sure how much you got, but I can use my thresholded data, which that's what only inside the Red Sea. And I don't have to display to use it, right? I can just select it and attach my streamlines to this data set now. And the streamlines I also often use filters, or we have a shortcut here. This is actually a pretty descriptive one. That's what streamlines are. Let's hit them. It's called actually a stream tracer. Again, so advanced properties, you have much more. I don't think we're going to need them right now. Most importantly is the vector field, which we want to use for generating the streamlines. And we have only that one, like before. So here, that's what I said before. You can actually, even in the non-advanced properties, you can choose what kind of Runge-Kutta scheme you want. We keep the default one. Let's keep both integration directions for now. I might talk about that a bit if we have time. You can set the maximum integration length. You can play around with that. And here the most important parameter is that, again, the same problem with an arrow plot is where you have to choose where to put the arrows. We have now to tell ParaView where to start the streamlines. And here ParaView provides two methods to provide the streamlines. One where you can specify a line and it will distribute points around that line and start integrating streamlines from there, or a point cloud. I think that the line is, in this case, actually pretty useful because the Gulf of Aden and Red Sea are rather elongated anyway. You see the line here. That's not a tricky part. You have to move it somehow inside. I'm not even finding it here anymore. If you know the numbers, you can just change. You see that the numbers change here. I don't actually know the numbers, so I'm trying to figure it out. The only good thing is, which I know, is I probably want to start the streamlines again somewhere at the surface, so I can use a small negative number here in the Z direction for both points. And now that actually looks already like pretty useful line. The problem is that the projection and the perspective makes it difficult to say if the line actually is inside the Red Sea, but in this case it seems it is, because we are always inside the... But anyway, let's just try integrating stuff. So once you... That's the tricky part, and that's then the visualization will depend a lot on how you specify your seed points. And there are different ways. If you need to generate the streamlines or want to use streamlines for your visualizations, I could probably do a whole workshop on that. Just get in touch with us. There are plenty of ways to do that in ParaView. I'm just showing the most basic ones and the ones that are available out of the box, which is here just a line. So once we specify the line, the most important parameter again is the number of points we want to now distribute along that line. 1,000 is much too much. Probably 100 is still too much, but I'll try 100. So it means now along that line that you see there, it will distribute equally 100 points, and from each point it will start a streamline and integrate it depending on the parameters up to this length and so on. Let's just see what it looks like. Just hit apply. There we go. That actually already looks quite nice, in my opinion. I was lucky. I found a nice position for the seed points. Again, once you like that, if you try to rotate now, you might interact with that line and change it. So I switch it off here. I'm not gonna use it anymore because I like that already a little bit. Because it shows in this case, we've seen it with the arrow plot already, but we essentially have four almost eddies in the Gulf of Aden. Nice challenge now. Homework. Try to visualize which way they're rotating. Hint: streamlines won't work. So and the next thing is they're also on top of the Red Sea because there's little movement downwards and upwards. So if you want to get some streamlines down there, we would have to specify starting points there somehow, but by putting a line or a point cloud somewhere. So that's how you can try to explore it. As I said, that's a tricky and very interesting part of visualization, finding good ways and good seed points for streamlines. If you need that, get in touch with us. I have a lot of experience with that. Otherwise, 3 minutes before closing time, right? I would say if there are any questions, let me see if I missed something very important. So here in this right image, you see that I have tried distributing the streamlines also lower into the Red Sea. You can play around with that yourself. I would have, if there was time, I would talk a little bit about some of ParaView GUI features, but they are rather self-explaining anyway. If you want to take a screenshot, there's a button, take a screenshot, or a menu entry. You can save and load states, which is useful. Once you've done something which looks cool, you just save it as a state, and next time, or if ParaView crashes, sometimes that happens, I can just load it again and go from there. And then you can link views and this much, many options. Not so important right now for the day. I want to, my last slide, repeat the motivation I had as a conclusion. So that's what we did today. The streamlines and the vector field visualization a bit rushed. My apologies. It always happens. I run out of time. But that's also much more complicated. And takes a lot of experience and practice to get nice visualizations for vector fields. So if you have some special problem, get in touch with us. We've also done all these scalar field visualization techniques. As I said, all these techniques are applicable now to all kind of data that produce either some scalars or some vector fields, and you can use ParaView for that. With that, time for questions. Yeah, let's do that.